Hello, this is section 3.4 on equivalent statements. So suppose your friend makes the following statements. If it is sunny, then we go to the beach. If we go to the beach, then it is sunny. If it is not sunny, then we do not go to the beach. If we do not go to the beach, then it is not sunny. Are these statements all saying the same thing, or does each one say something completely different from each other statement? So the two statements are equivalent. And this is the notation that we use for equivalence, a double-sided arrow, if both statements have exactly the same truth values. So let's go through some examples. So the first example says, determine which statement is logically equivalent to it is not true that the tire is both out of balance and flat. So let's define what P and Q would be. Let's say P would be the tire is out of balance. The tire is out of balance. And Q would be the tire is flat. So what the statement that they're saying is it is not true. So remember that it is not true part means that we're going to do a not, a negation, and then in parentheses we're going to follow up with whatever follows. The tire is both out of balance, so that would be P, and flat, that would be Q. So that's what the statement is saying. We got to figure out which of these four is logically equivalent to this statement. So we have to create truth tables for each of these to determine which of those it is. So let's start with down here. We'll call this one A. So let's see, for P, we have to go through the different combinations. P and Q can be true, true, or it can be true, false, or it can be false, true, or it can be false, false. All right, so now let's, the first one says, if the tire is not flat, the tire is not flat, that would be not Q, then that would be your conditional statement. Then the tire is not out of balance, not P. All right, so let's determine, that would go over in this column, sorry. Okay, now we can determine the truth value of this statement. This is part A. All right, not Q, then, if not Q, then P. So this would be not Q would be F, implies not P would be F as well. So that would be true. Whenever you have a false as your if part, then the statement is automatically true. All right. Let's look at the next one. Okay, so the next one says not Q. That would be true. If true, then not P would be false. That would be a false statement. If you have a true followed by a false, that means false. Okay, the next one would be not Q. That would be false. Implies true. Since it starts with the false, that means it's automatically true. And then the last one would be not Q, then not P. If true, then true, that is true. All right, now let's take a look at the next example. All right, the next one would be part B. That one says the tire is not out of balance. So that would be not out of balance would be not P, or the tire is not flat, or the tire is not flat. All right, let's take a look at these. Let's just write all the combinations again. True, 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 false, false, true, for the first one, it's going to be not P, that would be false, or not Q, which would be false. False or false is false. For or, one of them has to be true in order for the statement to be true. But since they're both false, that means the statement is false. Right, the next one's going to be not P is false, or not Q is true. Since one of them is true, that means the statement is true. The next one would be not P or not Q. One of them is true, therefore the statement is true. And then the last one is going to be not P or not Q. True or true is true because they're both true. Only one of them has to be true or both. All right, now let's look at C. All right, C says the tire is not flat. That would be not Q. And the tire is not out of balance, not P. All right, true, 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 false, false, true, false, false. All right, so let's start with the first one, not Q, and not P. False and false is false. All right, the other one, the next one would be true and false. They both have to be true in order for the conjunction to be true, so this would be false as well. All right, the next one says not Q, which is F, and not P, which is true. Same thing, false. And then the last one would be not Q and not P. True and true is true. All right, then the last one is part D. That says if the tire is not out of balance. So that would be not out of balance would be not P. Then, so that's the arrow, the tire is not flat, not Q. Okay, so once again, true, 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 false, false, true, false, false. All right, this would be not P, then not Q. If you start with the false, that means it's true. All right, next one is not P implies not Q. All right, false implies true. That is true because you're starting with the false. All right, not P implies not Q. True implies false is false. And the last one is true implies true. That is true. Okay, so now we can determine which of these is, well, we didn't really fill this one out, so let's fill this one out first. So true, 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 false, false, true, false, false. All right, so let's do the inside part, and then we'll negate it after. So P and Q would be true, and true is true, but then you take the negation of true, which is false. All right, the next one would be true and false, which is false, but the negation of false is true. The next one would be false and true, which is false. The negation of false is true. And then the last one would be false and false, which is false, but the negation of false is true. All right, so then you just compare the truth values to see which one is equivalent. So it should be FTTT. So that one's out. There we go. We found an equivalence. That one's out, and that one's out. So these two are logically equivalent. So the answer was B. All right, so that was the answer. So these two statements are logically equivalent. It is not true that the tire is both out of balance and flat. Is equivalent to the tire is not out of balance or the tire is not flat. All right, so that's how you determine whether two statements are logically equivalent. You fill out their truth tables and you look at which one has the same truth values. All right, De Morgan's law. This is what De Morgan's law says. It says that if you have a negation of a statement, such as this, that is the same thing or equivalent to, double-sided arrow. Basically, think of this as distributing the negation. If you distribute the negation, that becomes not P. When you negate and, it becomes or. And when you negate Q, it becomes not Q. So you get the statement not P or not Q. So that's what De Morgan's law says. So let's do another version of it. P or Q. Same thing. Distribute the negation, and you'll get not P and not Q. So when you negate or, it becomes and. All right, let's do a couple more. How about the negation of the statement not P or Q? De Morgan's law says that the negation of not P is P, the negation of or is and the negation of Q is not Q. All right, and then the final one, let's do one more. Let's do P or not Q. That's logically equivalent to not P and Q. All right, let's move on to the next page. Which of these are equivalent to the original statement? I do not have investments, but I do not have debt. So let's define P and Q. We'll say P is the statement, I have investments. And Q will be the statement, I have debts. All right, so this statement would become, I do not have investments. That would be not P, but that means and. I do not have debt, so that would be not Q. All right, so I do not have investments or I do not have debt would be I do not have investments or I do not have debt would be not Q. That's how you would write that statement. It is false that I have, so it is false that. Start that off with the negation with the parentheses, and then you write this statement in the parentheses. I have investments, that would be P, and I have debt. All right. Next one, same thing. It is false that. So same thing, negation, parentheses. I have investments, that's P, or I have debt, that's Q. All right, I have investments or I have debt, that would be P or Q. All right, so we've gotten through that. Now let's go to example 3. Use De Morgan's law to write an equivalent statement. All right, the pot roast is hot, but it is not well done. So let's call this P. And then this would be not Q because of the word not. So negation Q because of the word not, but that's going to be an and, right? So our statement would be P and not Q. All right. So they want us to write an equivalent statement using De Morgan's law. So what we can do is, since we want to write an equivalent statement, let's do our double-sided arrow. And then we will do the negation on the outside. And then so we want the opposite of P. That's going to be not P. We want the negation of and, which is an or. And then we want the negation of Q, not Q, which is Q. So that would be our equivalent statement using De Morgan's law. All right, so in order to write that, we would have to write, it is false that. And then we follow up with the statement that's inside the parentheses, which is the pot roast is not hot, or it is well done. All right, so we use De Morgan's law. It is false that the pot roast is not hot, or it is well done. All right, let's look at the next one. The hotel does not have a weight room. So does not have a weight room, that would be not P. There's your or. The conference center does not have an auditorium. So not Q. All right, so the statement is not P or not Q. If we use De Morgan's law, let's write the equivalent statement. So negation on the outside of the parentheses, that would have to become P and Q. So basically you just do the opposite, 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 which is positive and Q, and the negation comes to the outside. Then we can write the sentence in English, which would be, it is false that the hotel has a weight room and the conference center has an auditorium. All right, here's it is false that the hotel has a weight room and the conference center has an auditorium. All right, so these two statements are equivalent. All right, let's look at the next example. Benjamin Franklin was not a U.S. president, so that would be not P because of the word not. But, that's an and, he signed the Declaration of Independence, that would be Q. So not P and Q is going to be equivalent using De Morgan's law with negation, P or not Q. All right, so let's write that. It is false that, or it is not true that. You can write that any way you want. It is false that Benjamin Franklin was a U.S. president, or he did not sign the Declaration of Independence. All right, so that's how you would write that out. All right, the next example, or the next topic is converse, inverse, contrapositive. So let's take a look at this. All right, so let's fill out this table, this truth table. So we have true, 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 false, false, true, false, false. Those are all the combinations. And we know that true implies true. If T, then T is true. We also know that if T, then false is false. And if false, then true is true. And if false, then false is true as well. Whenever a conditional statement starts with an F, the conditional statement is always true. All right, the converse would be when you reverse those two letters, Q, if Q, then P. All right, so let's see if that's true or not. So if true, then true. We know that's true. All right, the next one would be if false, then true. That is, let's see, a false and true. Yes, that's true because it starts with the false. The next one would be if true, then false. That's false. And the last one is if false, then false. We know that that's true because it starts with the true. Starts with the false. Sorry. The inverse would be when you do the negation of P. If not P, then not Q. That's by definition what the inverse says. So let's look at this. This would be false. If false, then false. That's true. The next one would be if false, then true. That's also true because it starts with the false. The next one would be if true, then false. That's our false statement there. And finally, if true, then true is also true. So I'm going back to the originals and I'm negating both of them, and then I'm checking to see if the conditional is true or false. The contrapositive is when you reverse the letters and you also take the negation of them. So not Q, if not Q, then not P. All right, so let's look at this one. Not Q would be false, and not P would be false. That's true. Not Q is true, then not P. If true, then false. That's false. And then the next one would be if false, then true. That is true. And the last one would be if true, then true is also true. All right, let's put this into action. If your cell phone is beeping, then you need to charge the battery. All right, so let's look at what the that would be our P. If then, this would be our Q. All right, so let's write the contrapositive. The contrapositive is when you just do this negation and you also reverse the letters. So Q goes first and then P, but you have to reverse them. So not Q, if not Q, then not P. So if not Q, if you don't need to charge the battery, then your cell phone does not beep, or your cell phone is not beeping. Your cell is not beeping. Sometimes these sentences will sound a little funny, but the important thing is that they're logically equivalent in some cases they're not, depending on, for example, these two would be equivalent because they have the same truth value. True, true. So this original statement is logically equivalent to that statement. Okay, because their truth values are the same. All right, the converse, let's look at the converse. The converse would not be logically equivalent because, as you can see, they don't have the same truth values. But let's write it anyway. So that would be Q, if Q, then P. So if Q, if you need to change the battery, charge the battery, then your cell phone is beeping. All right, the inverse is going to be not P. If not P, then not Q. All right, if not P, if not P would be if your cell is not beeping, then not Q would be then you don't need to charge the battery. All right, so in summary, let's write this the summarization down. The summary is that these two are equivalent because they have the same truth value, and these two are equivalent because those two have the same truth value. So let's write that. Conditional is equivalent to contrapositive. All right, so if P then Q is the same as not Q, then not P. All right, and then the other two are the converse is equivalent to inverse. And that just says that Q, if Q then P is equivalent to not P then not Q. All right. All right, so the last example, and then we are done. If you leave by 9 a.m., that would be RP. Then, that's your arrow, you will get to your house on time. That is your Q. All right, so let's start with the contrapositive. The contrapositive is here, not Q, if not Q, then not P. If not Q, so if you don't get to your house on time, then not P. Then you didn't leave by 9. Then you didn't leave by 9. Right? The converse says if Q then P. If Q, if you get to your house on time, then, so the converse once again, if Q then not P, if then not P would be, if Q then P, sorry, then you left by 9. Okay, and then finally the inverse says, if not P, then not Q. If not P, if you don't leave by 9, then not Q, right? Yeah, not Q. Then you will not get to your house on time. Then you will not get to your house on time. All right, so just to summarize, remember the conditional and the contrapositive are equivalent. So here's your conditional. That is equivalent to the contrapositive. Those two statements are logically equivalent. And then these two statements are logically equivalent, converse and inverse. So these two down here basically mean the same exact thing. And that concludes this section.